In addition to enabling a derivation of Maxwell's equations, the ether model presented here also provides several other important and interesting results. A first result is that the scalar potential in this analysis satisfies the equation that the gradient of phi is equal to 4 pi rho sub 0 times the quantity n sub l minus p sub l. Here, n sub l is the longitudinal component of the vector field that is the separation of the negative attached ether from its equilibrium position, whereas p sub l is the same quantity except for the positive attached ether. Since we know that the attached ether obeys the equation that the transverse components of the motion are equal for both the positive and negative components, that then means that n sub t minus p sub t is 0, and therefore n sub l minus p sub l is equal to n minus p. And when we recognize that the static electric field is the gradient of phi, that then tells us that the static electric fields are nothing more than the distance that the positive attached ether is separated from its negative counterpart. Here we see two depictions of the positive attached ether. The picture on the left shows an undisturbed ether, while the picture on the right shows the case where a cylinder of detached positive ether has been inserted. I've colored the attached ether green and the detached ether blue here. Since the ether is incompressible, when we insert the detached ether, it must push the attached ether out of the way. Vectors show some of those displacements. You can see how some ether that was in the middle of this picture originally gets pushed out to the outer ring, whereas one that starts in the second ring gets pushed to the third ring, something that was starting in the third gets pushed to the fourth, and anything that was in the fourth ring gets pushed outward to the fifth ring. As can be seen, the further away the original attached ether is from the center, the less it needs to move out of the way. This tells us how we get to the equation that for a cylinder of charge, the electric field will fall off as 1 over r. It's nothing more than the distance that the attached ether has to move to get out of the way as we put the detached ether in the middle. Back in graduate school, I had a student who wanted to know what the electric field was. At that time, there was no good answer. Now we can recognize that a static electric field is a quantity that is proportional to the separation of the positive ether from the negative ether. We can finally tell students what the electric field is. A second result of the model presented here is that we can now also answer the question of what the vector potential is. The vector potential is the transverse component of the displacement of the attached ether, for both the negative and positive cases. As we saw earlier, both the negative and positive ether have the same equation of motion for their transverse displacements. We can also identify light as a transverse wave on the ether, which is crudely shown in the diagram here. Both the positive and negative ether will move together in light waves, and since the ether is a solid, transversely polarized waves are supported in the usual way. A third result of the model presented here is an answer to the question of how bodies can traverse through a solid ether without slowing down. The answer to that question comes from our proposed force law that stipulates that the flow forces are in one direction for positive ether and in the opposite direction for the negative ether. Hence, the reaction force on all charged particles will be 0 as those particles traverse the ether. Since all bodies are constructed of charged particles such as electrons and quarks, those composite bodies will also pass through the ether with no change in energy. Another set of results are shown on this slide. First, as mentioned earlier, the law of charge conservation is easily obtained from the model proposed here. Since charge is identified as detached ether, we see that whenever positive ether becomes detached, it must become detached from negative ether, freeing an equal amount of negative ether in the process. The absence of magnetic monopoles also follows from the model proposed here. When written in terms of the electric and magnetic fields, Maxwell's equations have a certain symmetry that has led many people to propose that a magnetic charge should exist alongside the known electric charge. But by the model proposed here, it is seen that the physical entities underlying Maxwell's equations are entities that are described by the scalar and vector potentials in the Coulomb gauge, and in that form the symmetry argument for the existence of a magnetic monopole no longer exists. In fact, there is little room for a magnetic monopole in the model proposed here. Positive electric charge is identified as detached positive ether, and negative charge as detached negative ether. There is no similar substance to form magnetic monopoles in this model. Third, the model proposed here unifies charge currents and the displacement current in a physical way. What are understood as currents in the usual sense are charges in motion, with the current being the charge times the velocity. In the model proposed here, that is detached ether times its velocity. But in this model, the displacement current, which is the time derivative of the electric field, is determined to be the velocity of the attached ether, as can be seen here. Since P and N are the displacements of the attached ether, we see that one component of the displacement current is simply the velocity of the attached ether. The other component involves the vector potential, which is also proportional to the displacement of the attached ether. Hence, both normal currents and displacement currents are unified in the understanding that they both involve motion of quantities of ether. An important aspect of the theory presented here is the new concept of negative mass. It is often the case that physics advances by new conceptual breakthroughs, and for the theory proposed in this webinar, negative mass is quite necessary. If we again return to our force equations, we should recall that it is the presence of the negative mass that allows the equation for the negative attached ether to be the same as that for the positive attached ether. And that equality was a crucial aspect in allowing us to arrive at Maxwell's equations. While we could possibly change the flow force laws so that negative mass is not required, such a change in the flow force laws would result in a situation where the reaction force back on the moving charge is non-zero. Hence, for these reasons, negative mass is needed in this theory. Note that it is this concept of negative mass that has freed this ether model from one of the usual pitfalls of all ether models, as the model proposed here can readily explain why charged particles can freely traverse the ether. Additionally, with one component of the ether having a positive mass and the other having an equal and opposite negative mass, the total ether will have no net mass, and hence will not affect the gravitational fields of stars and planets. While the ether model presented here has many very nice features, it is a requirement for any new theory to be able to point to specific tests that will help to separate it from competing ideas. In order to be a difference, it must make a difference. If there is no difference that is predicted, then we are merely renaming things from other theories. And while it may be appealing and tell a nice story, it isn't really science unless some tests can be proposed. Here there are two tests that can be done. First, it is known that as entities travel through space, their processes slow down. In the ether model proposed here, light is an oscillation of the ether, and therefore light is ether in motion. Since clocks traveling through the ether slow down, by the theory proposed here, clocks immersed in electromagnetic waves should also slow down. Now the effect may be quite small, since the theory here gives no guide as to how large the oscillations are, but the effect should be observed at some level. A second test should be possible for low-velocity particles in electromagnetic wave environments. Recall that in our derivation of Maxwell's equations, we neglected terms involving the density of the detached ether multiplied by the velocity of the attached ether, since they are typically small in comparison to other terms used in the derivation. But for the case where the velocity of the detached ether is small, namely when a charged particle velocity is small, and the intensity of the attached ether oscillations are large, this approximation will begin to break down, which should yield experimental differences. In conclusion, an incompressible, solid, two-component ether model has been presented in this webinar that allows a rigorous derivation of Maxwell's equations starting from a simple flow law and a simple tension law. Many explanations readily follow from the initial assumptions. It is seen that light is a transverse wave on a solid. Charge conservation results from the detachment of ether. The lack of magnetic monopoles is understood. The mechanism for displacement currents is readily apparent. And one of the nagging problems of all ether models is solved, as it is explained how bodies can freely move through the ether. Importantly, tests are possible to help determine if the theory is accurate. And, as with all advances in science, there is room for future study. Since the model here shows how charges lead to forces that create electric and magnetic fields, it remains to derive the Lorentz force equation in a way that is consistent with the model. It also remains to experimentally evaluate the constants defined for the theory, which are small a, rho sub 0, and t sub 0. Thank you for taking the time to evaluate this ether model. If you have any questions or comments, please write me at delbert@larsonism.net. I intend to use such comments to further strengthen this work, and if a vigorous conversation begins, I expect that there will be improvements in the presentation as a result. I look forward to hearing from you.